Okay, hi guys. So in this lecture, we'll be discussing on the mechanism of hydroboration oxidation. Okay, so let me start off. Hydroboration oxidation is nothing but the HBO, which I mentioned as a short form in past lecture. Okay, so let's get started. So in the first step, what will happen is we have this alkene. Okay, and we have in the first step we have BH3. So what will happen here is this bond would be breaking up, and as a result this H would be attaching to this middle carbon because of partial positive nature of this carbon atom. Okay, and as a result we'll be getting something like or rather let me make the intermediate first. Okay, we'll get something like okay, so what will be happening is this bond will be breaking at the same time. Okay, and this B would also have a delta negative. Okay, H and H here, this is the transition state. This would be having delta positive. Okay, so let's discuss what happens after this, or rather we can say that this carbon atom is having a delta negative. So what actually happens is, this BH3 is a electrophile, right? So what will happen is the double bond between this carbon atom and this carbon atom will be breaking up to create a partial positive and partial negative on this carbon atom. Obviously it makes sense more to have a partial positive at this carbon atom and partial negative at this carbon atom. Has it been the opposite, that means negative on here and positive on here, negative would be highly unstable because of presence of two inductive effect or two plus H effects nearby to this carbon atom, whereas negative on this carbon atom would be more stable because of obvious reasons. Okay, so negative would be here, that would be attacking on the B atom. As a result, H minus will be leaving and attaching on this carbon atom with a partial positive charge. Okay, as a result we will be getting something like H attached here. Okay, now what will happen is again the alkene molecule will again attack on this B, and this H will be attached to this carbon atom. Okay, so we'll get something like one H still remaining here, and CH2, CH2 and CH3. Okay, now what will happen is again one alkene will come and attach on this boron atom. Okay, this H being attached to this carbon atom. As a result we'll be getting something like one group here, one group here and one group here. So three groups, three propyl groups attached to the boron atom. Okay, so what will happen is in the second step, when we pass it with H2O2 or peroxide in basic medium, what will happen is the OH minus would obviously react attach on or attack on this carbon atom. As a result boron will be leaving. Okay, and we'll get something like CH2OH as the final product. Okay, and if we react it with, let's say, if we react it with CH3CO2D, then what will be happening? This D would be attaching on this carbon atom, and the attachment of D would be syn with the hydrogen atom which been attached from the BH3. Okay, because both the two were attached from the same BH3 group, and BH3 was in this place before the D, and this would be replaced by D, so it's a syn addition. Okay, so first step is obviously that in H2O2 in peroxide, boron is replaced by OH. Okay, second would be it is a syn addition. Some notes here. Okay, it is a syn addition. Okay, so with this we complete the mechanism of OMDM and HBO. Okay, I hope you remember the mechanism. Even if you don't remember the mechanism, just remember that it is an example of Markovnikov rule with no rearrangement, and this is example of anti-Markovnikov rule again with no rearrangement. Okay, so let's start off with a new topic which is very important for the as far as the JEE level preparation is concerned, which is Kucherov reaction or hydration of alkene. So just start it. Kucherov reaction, which in other terms you can also say hydration of alkene. Okay, so we have this and impedance of HgSO4 and dilute H2SO4, we'll get something like this. Okay, so we'll come to the reverse cycle, so as in how it is getting formed. Okay, so let's come to it. So what will happen in the first step is this alkyne is being acted upon with Hg+2. As a result, we'll be getting something like this product. Okay, and on reaction with water molecule, what will happen is, as this is having a water molecule, will actually attack either on which carbon atom should the water molecule attack on. Obviously this, why? Because of obvious reasons, more alpha hydrogen here, so water molecule will attack here, and we'll get something like and simultaneously the Hg and this carbon bond would be breaking up, and we'll get something like this. This was in +2 state, now it is in plus state because of one bond electron from the carbon atom. Okay, now what will happen is, again this bond would be breaking up. Okay, and again the Hg would oxidize itself as this carbon atom takes back its electron and attack on this H+, which will be obviously breaking from the O+ atom or ion, because O is having positive charge and it will try to get rid of H+ and in the way of itself to become a neutral oxygen molecule or atom. We'll get something like this double bond and CH2 here, which on tautomerism, which I erased here, will get us a ketone form. Obviously plus Hg+2 would be released. Okay, so first reduction of Hg took place and then oxidation. So reduction, then oxidation. Okay, let's discuss one example before ending this lecture. Okay, we will have something like this and this on reaction with Hg+2 in dilute H2SO4. Kucherov reaction will take place, hydration of alkyne will happen, This is not alkene, this is alkyne, I beg your pardon. Hydration of alkynes. Okay, hydration of alkynes will take place, in which we'll get something like, again we'll be getting in the intermediate step this plus Hg2 plus 2 would be released here. Okay, this step and Hg plus 2 I'm just showing here, which on going to tautomerism will have something like a ketone group, something like this. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the hydration of alkynes. So till then, good luck and goodbye.